Okay, welcome to Math 31, Section 2.6, solving equations using the addition and multiplication properties of equality. In this first section here, what we're going to do is take a given value. You'll see that in example A, you're given a 12, and you're just going to see if it actually is a solution to the equation that's also given to you. You'll do that by plugging in the value 12 where you see the variable x. So we'll do that to start with. And 12 plus 13 equals 25, and then 25 equals 25 is a true statement, and because of that, the answer we want is yes, 12 is a solution to x plus 13 equals 25. So when you get a true statement at the bottom after all the calculations are done, then yes, it is a solution. Okay, so the next example here, you can see that we're going to be using a -4 wherever it says k. So we'll be plugging in the -4 in the place of k. And this time, we get -13 equals -5, which is false. And so no, -4 is not a solution to the equation. Okay, we'll do a couple more of these. You can see that the value we're going to be plugging in is -6, and we're going to put it in for the variable w. So here's the calculations for that. There is a double negative in there where it says on the second line 14 minus -18, and that becomes just a plus. And you get 32 equals 32 is the upshot, and since that is a true statement, then yes, -6 is a solution to the equation. You're trying to find the value that makes the equation true. All right, we're given a -5 here on the next problem. -5 will replace the n and the other n. Both of those get replaced by the same value, -5. Let's see where this leads us. You can see I substituted -5 in where it used to say n. Actually, let me get the right tool. You can see I put a -5 in both places where it used to say n. And then working it all out gives 18 on both sides. And since 18 equals 18 is a true statement, we say that -5 is a solution to the equation. In the next section, we actually are supposed to solve it, which means find the solution yourself instead of testing to see if one that you are given is true. So here we have the equation w minus 6 equals -2, and our goal is to find the number that you could plug in there that would make that a true statement. Well, what we're going to be doing in this section is counteracting the actions that are done to the variable. In this case, we're subtracting 6 from w, so you're going to counteract that by adding 6 to the other side. There we go. You're going to add 6 to the other side. Sorry about that. Okay, so w equals -2 plus 6. That's how I want you to learn to do it. I will show you another way in a second here, but we get our answer very quickly and efficiently, 4. Now the other way, I'll do it in blue here, that I've seen people learn how to do this is to show the addition on both sides by going +6 and +6 and drawing a line here. Then these cancel off, which is why I didn't bother to write them. And instead, what used to say -6 on the left-hand side just becomes +6 on the right-hand side. That's the shortcut. But anyway, you get to the same answer both ways. I'll let you do it both ways, but I'll strongly encourage you to do it the way I'm trying to do. All right, so let's see what we get here. We're adding 19, so we're going to counteract that by subtracting 19 on the other side. 14 plus -19 is -5. So the solution is -5. Okay, on G and H, we're actually dealing with multiplication and division. And you counteract multiplication. That right there means -7 times t by dividing. So instead of multiplying by -7, we divide both sides by -7. On this side, it cancels off because it gives 1. -7 divided by itself is 1. And we get -42 divided by -7, which is 6. Okay, you counteract division. We have a division here by multiplying. So instead of dividing by -3, you're going to multiply both sides by -3. It cancels off this side since it gives 1. So we get 1 times k, or just k. And on the other side here, 18 times 3 is 54. But it's actually 18 times -3, so it's -54. And you can see the negative sign there changes it to the answer to -54. Okay, 2 more here before we move on to the next section. -4 times q equals 0. We'll counteract the multiplying by -4 by dividing both sides by -4. And we get q equals 0 divided by -4, which is just 0. Okay, on example J, we're going to add 124 to both sides, which makes it simply disappear on that side. It's as if a minus on one side becomes a plus on the other. That's the most efficient way to, or a very efficient way to get this done, and that's what I'm going to have you guys doing. And now let's just off to the side do some ciphering here. 124 plus 85 is 209. So there's our solution, 209. Okay, the last section here is just more practice with translating from words into mathematical symbols. And there's some tricky stuff in here, okay? First of all, the product means multiplying, so we're going to be multiplying where it says and. And I think I have that written out here for you. Let's see what this looks like here when I uncover it. Yep, -12 times x. With the dot or without the dot, the preferable one is the one without the dot. So this is actually the one we prefer. Quotient means divide, so we're going to be dividing a number by -3, and you write that using the fraction bar. You can actually do it this way, although I don't advise it. Kind of an awkward set of symbols when you have two symbols up against each other. Okay, on example M, we want 8 less than twice the number. Now, less than means subtraction, but you have to reverse the order in which it's presented in the original sentence. So the -8 is written in front to start with, but you write it behind the minus sign when you put it on paper in mathematical symbols. Example N is also a reversed subtraction. It says subtract 5 from a number, and you can see that I put the 5 behind the subtraction. The last two are also subtraction, but they aren't reversed. So when it says a number decreased by 8, you just say x minus 8. And then finally, a difference of a number and -2, that's also subtraction, but it isn't reversed. So you just take the number and subtract -2, and you're done. Okay, so I hope this helps you with section 2.6, and you'll find these problems reasonable to finish